In this video, we're going to be taking a look at nets and surface area, and you'll need to get out your Go Math book and turn to page 419, your math journal, and a pencil. You will also need to get graph paper from me as well. If you're at home working or watching this video, you can print out some graph paper from the internet. That will work too. So let's take a look at, first of all, using a net on page 419. And it says a net is a two-dimensional pattern of shapes that can be folded into three-dimensional figures. The shapes in the net become the faces of the three-dimensional figure. So you can see two-dimensional means it does not have length, width, and height. Okay, so you can see these are an example of two-dimensional objects in the upper right-hand corner, a three-dimensional object. Now what it says is copy each net on graph paper. Cut out each net along the blue line. So I want you to do that in your graph paper now. And when you're finished with that, you can press play and keep watching this with us. Now, it says one of these nets can be folded along the black lines to make a cube. So I want you to fold these nets along the black lines to make a cube. Now we need to figure out which net will not make a cube. And we can see after you've folded those nets along the black lines, we can see net B will not make a cube, and I want you to write that down as well. Now for letter B, it says on your graph paper, draw a different net that you think will make a cube. I want you to do that. A couple things that we know about cubes, first of all, is we know that they have 6 faces, so make sure your net at least has 6 faces. And then what I want you to do is confirm by cutting out and folding your net. So try to fold your net a certain way to form a cube. You're not able to compare your results with classmates or anything like that. Now, let's see if you're able to do that, and you can just do that on your own. Now let's take a look at the reflect questions there at the bottom. It says, how do you know that each net cannot be folded into a cube without actually cutting and folding it? So you can see for number 1, we talked about a cube has 6 faces. 1, 2, 3, 4, 5. This net only has 5 faces, but a cube has 6. You can write that down for number 1. Now let's take a look at number 2. We can see it has 1, 2, 3, 4, 5, 6 faces. However, if you were to fold this, the net folds into a loop of squares with no top or bottom. We know a cube has a top and a bottom. Okay, so that would not work either. Okay, so those are the 2 different reasons why they would not work for numbers 1 and 2. Let's take a look at number 3. It says, what shapes will appear in a net for a rectangular prism that is not a cube? How many of these shapes will there be? Okay, so we think about rectangular prisms. Okay, so what shapes will appear? We know that since it's a rectangular prism, rectangles, let's write this down. Okay, now with a rectangular prism, just like a cube, in that it has 6 faces. So you can see this would be an example of a net of a rectangular prism, and we can scroll up. This would be an example of a net of a cube, so you can see just 2-dimensional figures that can be folded in order to make a 3-dimensional figure. Now if you remember from the video, that the net of a cube for net A looked different than the one I just showed you, and that is true. You can have different nets. You can set up the nets differently, and they can still make identical shapes as well. So now let's take a look at knowing what we know about nets. Let's take that knowledge and let's apply it to surface area of a pyramid. Now, surface area of a 3-dimensional figure is the sum of all the areas of its faces. A net can be helpful when finding surface area. So, in other words, instead of looking at this square pyramid on the right and trying to figure out all the different areas and dimensions and shapes, we can just make it into a net, make it a lot easier that way. A couple things about a pyramid. A pyramid is a 3-dimensional figure whose base is a polygon and whose other faces are triangles that meet at a point. Okay, so polygon, closed 2-dimensional figure made up of line segments. So a pyramid is identified by the shape of its base. Okay, so we can see, first of all, it's a square pyramid. So right away we know square, we can see on example 1, we know that the base is going to be a square. So you can take that square pyramid, and what you need to do is you need to find the area of the square and also the area of the triangles. Now I want you to do this on a separate sheet of paper with me. Now the first thing you need to do is find the area of that square. Okay, and we know that, and let's write this out together, area of the square, area equals side squared, or side times side, and the area of this square equals 16, because that's the length of one side, times 16. So area of that square equals 256 inches squared. Let's write that. I always like to write it in the different spots that are represented by it. So we know that's 256. Now we're not finished yet, because what we have to do is we have to find the area of a triangle. And then from there, we're going to multiply each of these to multiply the triangle by the area of the triangle by 4, because we have 4 different triangles. Okay, so area of a triangle, area equals 1/2 base times the height. And we're going to write in area equals 1/2. The base is 16. 1/2 times 16 times the height, which is 17. So let's write this together. So area equals 1/2 times 16. An easier, maybe not be an easier, but another way to figure this out is think about 16 divided by 2. That's going to give us 8. 1/2 times 16 equals 8. 8 times 17 now. And we now know that area equals 8 times 17, and 8 times 17 equals 136. Now it's the area of one triangle. We're going to take that 136 and we're going to multiply it by 4. That 136 multiplied that by 4 is going to give us 544. Square inches for all the triangles. Now you're going to take that 544. We're going to add the 256 to that. That's going to give us 800 inches squared for the surface area of that square pyramid. Now, even though it's surface area, we're still dealing with square inches because it's area. Now let's take a look at this pyramid on page 420. What we're going to do is we're going to draw the net first together, and then I'm going to have you find the surface area. So we can see it's a square pyramid. Why do we know that? 16 by 16. Okay, so the first thing we do is we're going to draw our square just the best we can. I want you to do this with me. So we have 16 by 16. Actually, we'll write the 16 in the middle of that square so we can draw our triangles then. Okay, so 16 by 16. Now the next step, we're going to draw our triangles. Just do this the best we can. You can see my drawing is lovely here. So there we go. So 16 by 16 on length and width of the square. Now we need to look at the height. Okay, so we can see the height is 20 inches. It's going to be the same all the way around. So now that you have the measurements of this square pyramid, I want you to find the surface area. I want you to work on that now. Now you can see the surface area for the square pyramid is 896 inches squared. I want you to check your answer. Make sure it's the same as mine. If it's not, you can even rewind this video and see the previous problem we just went over. Now we're going to take a look at surface area of a prism. And a prism is a three-dimensional figure with two identical and parallel bases that are polygons. That's important to understand. The other faces are rectangles. A prism is identified by the shape of its base. Okay, so we're going to take a look at the formula for surface area of a prism. Now let's take a look at this rectangular prism. Okay, this prism is actually number 3 in your Go Math book on page 422. So we have surface area for a rectangular prism. Formula: surface area equals length times the width. 2 times length times the width, plus 2 times length times the height, plus 2 times the width times the height. Why is it 2? Because think about it, there's a front and a back, there's a right and a left, and there's a top and a bottom, and each of these will have the same measurements. Now what we'll do is we're going to plug in all the numbers for these different measurements. So we think about it, we are going to find the length times the width. Okay, so we're going to write this out. Let's do this together. So 2 times the length, and don't get too caught up on length and width, length and height and all that. If you can just figure out, for example, the front, the top, and then the right, you can figure out the surface area. So we can say 2 times 10, so we're going to do the front one, times the height of this front rectangle right here. So I can see that 10 and 4. Plus 2 times, look at this right figure, the right rectangle here, 6 times 4. Why is it 2 times 6 times 4? Because there's a right and a left side. Plus 2 times, we're going to find that top. We know it's 10 by 6. So 10 times 6. Now we're going to do order of operations. So in other words, we do parentheses first. So we have surface area equals, we'll write the 2 times 10 times 4 is 40, plus 2 times 6 times 4 is 24, plus 2 times 10 times 6 is 60. Why is it by 2 again? Because there's a front and a back, there's a top and a bottom, and there's a right and a left, all have the same measurements. So now we do 2 times 40 gives us 80. So what that does is that gives me the measurement of both front and back rectangle. 2 times 24 gives me 48. That gives me the area for the right and the left rectangle. And now 2 times 60 gives me the area of the top and bottom part of my rectangular prism. Now we add everything together up. 80 plus 48 is 128, plus 120 is 248 inches squared. So for number 3, find the surface area of one box, 248 inches squared. Let's write that out. Now for letter B, find the total surface area of 100 boxes. So what you do is you take 248, multiply that by 100. That's going to give us 24,800 inches squared. Now the question is, 1 can of paint will cover 14,000 square inches. How many cans of paint will Yolanda need to buy? So we have 224,800. We're going to divide that by 14,000. That's going to equal 1 with a remainder of 10,800. And since there's a remainder, how many cans of paint will she need to buy? She'll need to buy 2. So wrapping up this video, let's look at the essential question check-in. It says, how is a net useful when finding the surface area of prisms and pyramids? A net shows a 3-dimensional figure as flat and 2-dimensional, which makes it easier to visualize the shapes of the surfaces and add up their areas. So this concludes the video on nets and surface area. If you have any questions about this concept, please come and see me.